Hi Doctor, this video is about our IoT project, which is Disaster Detection System, prepared by Jason Liang Senjun and also me, Taiwan Jie. So the project overview is that the purpose of this project is to address environmental hazards. The IoT technology is applied for real-time detection and also automated response. The three main sensors is DHT11, MQ2, and rain sensors. The servo motor will act as our actuators to close or open windows. LED will be using for visual alerts and Google Cloud Platform, and also MQTT will be using in our project as well.
Hello, doctor. So this is our IoT project. So for our IoT project, we are actually doing disaster detection system. So we are doing three sensors. So first is rain sensor, the second is MQ2 smoke sensor, and the third one is DHT11 sensor. For our actuator, we have our motor servo for closing or opening doors and windows in case of disaster. So first of all, we have our data, which is collected and fed through, this is for our Arduino. So we have temperature, smoke level, and our rain. So let's try our motor servo. So whenever the smoke sensor has reached a certain threshold, the motor servo will work. So let's try it out. Okay, so the motor servo just turned just now, and as you can see in the terminal, the smoke level is 1000 and it says it's too high. So that's why the motor servo is working. So to detect flood in any case of a disaster, we are using a rain sensor. So let's try it out. So as you can see in the terminal, rain is actually not detected right now. So if we pour some water on our rain sensor, okay. So as you can see in the terminal, rain is actually detected, and the data will be fed to our MongoDB database.
For SDG alignment, the disaster detection system supports Sustainable Development Goal 13, which is climate action. These systems not only mitigates the immediate threats posed by the climate-related hazards, but also promote long-term climate resilience by enabling communities to better prepare for, respond to, and also recover from environmental challenges. In doing so, the disaster detection system shows the use of innovative technologies to promote sustainability, protect vulnerable populations, and also build a climate-resilient future.
So, as we saw in the live demonstration overview, our data for our project is fed into the Arduino, and in this Arduino, it is connected to our GCP VM instance. So, let's open the SSH terminal for our GCP VM instance. Okay, so for our instance, this data that is connected to our Arduino is actually fed into uh, our database through the MQTT broker. So now we perform our script. So this script is to push our data into the MongoDB database. Now, as we can see, our data that is ingested is going into the MongoDB Atlas database. So now, let's go to our MongoDB database. We can browse collection. Now, in our IoT structured database, we have our data. So our ID, sensor type, temperature, humidity, and our timestamp. So for this data, it can be actually visualized. So let's go to MongoDB charts. Now, this is an example of our visualization. So let's take a smoke level and timestamp, and we can make them into a discrete line. So our timestamp will be the x-axis. So let's change it to second. And our smoke level will be the y-axis. And we will change this to mean. So we can actually select a title. So this title will be smoke versus time. And now, as we can see, our visualization is complete, smoke versus time. So our data collected is actually for every second, the mean of our smoke data will be visualized. And that is our visualization for our workflow of our IoT. Thank you.